Hello and welcome to lesson 66, prime factorization. I've been waiting to teach this to you all year, and so here it goes. Prime factorization can be solved two ways. You could do the factor tree, or you could do division by primes. Now most students tend to like the factor trees because they're more visual. However, division by primes works as well, and it really works well with really big numbers. So learn both methods and use both methods however you'd like. Okay? Now, when it's asking you to find the prime factorization of a number, they're asking you to find the prime numbers that you can multiply to make the number they're looking for. Okay? So sometimes they'll ask you, find the prime factorization of 60. And sometimes they'll say, find the product of prime factors that make 60. It's the same thing, so don't let that confuse you. Okay? Let's do some examples from your book. Let's start with the factor tree, and let's find the prime factorization of 60. With the factor tree, you're going to start up at the top. And you want to write the number, and then put two branches coming off the 60, or whatever the number is, right? And you want those two numbers to multiply to make the 60. So what two numbers multiply to make 60? Well, 1 and 60 does, but don't ever pick 1. Okay, because your tree will just go on forever and ever and ever. But 2 times 30 does, and 3 times 20, and 6 times 10. You could do any of those. Okay, and you can keep going, and you'll get the right answer at the end. But you need two numbers that multiply to 60. Now, when you find one that's prime, that branch is done. So draw a leaf around it, or a circle, or mark it in some way that you know that number's done. That branch has ended because it ended at a prime number. 30 is not prime, so we need to draw two branches off 30. Now what makes 30? 3 times 10, or maybe 2 times 15. Just pick one, that works. But don't pick 1 times 30. And then, oh, we have another 2. Another branch has ended. Now 15, what makes 15? You're going to find you're only going to have one choice. 3 times 5, 5 times 3. 5 and 3 are both prime numbers. All of our branches have ended. Our tree is done, and we have a 2, 2, 3, and a 5. My answer is 2 times 2 times 3 times 5. Or since there are two 2's, since I have the number 2 and I have 2 of them, you could write squared times 3 times 5. Now notice I put my numbers in order from smallest to largest, and I also put this multiplication sign as a dot in the middle. You could put times with an X, but upper grades tend to put this little dot here. Okay? Not a decimal, floating right in the middle. Okay? If there was 3 2's, I would have put 2 cubed, 2 to the 3. You always put the number here, and then how many there are as the exponent. All right? That's a factor tree. Now, division by primes works a little different. And notice right away, I started at the bottom. Factor tree, you start at the top and work your way down the tree. Division by primes, you start at the bottom and you work your way up. Okay? Right away, helps you give a little visual on the difference between the two. Oh yeah, division by primes is the one where I go up. I remember what to do. Okay? Now, division by primes is exactly what it says. Divide by primes. So draw your number, write your number, draw a box over it, and divide by a prime number. Don't divide by 10, because 10 would go into it, but it's not a prime number. And whenever it's even, I usually just start doing dividing by 2. 2 is a prime number. Okay, it's very easy to divide by. So 2 goes into 30 15 times. I'm not done yet. Draw another dividing box. Now what goes into 15? Well, 3 goes into 15 5 times. Not done yet. What goes into 5? Well, 5 goes into 5 1 time. Now I'm done. When you get a 1 at the top, a 1 is neither prime nor is it composite. When you get that 1, you're done. But my answer lies right here. What are the prime numbers that I divided by? Product of prime numbers is prime factorization. So 2, 3, and 5, my answer is 2 times 3 times 5. That is my answer. And to check answers is very simple. You multiply your work and see if you get the number. 2 times 3 is 6. 6 times 5 is 30. 2 times 2 is 4. Times 3 is 12. Times 5 is 60. Both of them worked. And they're all prime numbers. If they're not prime numbers, then you did something wrong. Okay? Now, prime factorization is a big field. There's lots of math to do. I only did 2 of the work from your book. You have to find division by primes, find the factorization of 72, different things like that. If you have more questions, come and see me. I'd be glad to help. I think you'll get a hang of prime factorization with a little bit of practice. Thank you very much, and good luck. Bye.